Well, hello everybody, and welcome again to another OpenShift Commons briefing. This time I've asked Michael Hausenblas and Brian Gracely to give a prequel to a lightning talk that Michael is going to give at KubeCon EU coming up, I think, on May 1st. Lightning talks are very short, very succinct. You have like 5 minutes and maybe 5 slides to do it. But it's a topic that deserves a little bit more time, and I thought that as a prequel, we could get Michael and Brian to sort of pontificate on the state of FaaS, or function as a service, on Kubernetes, and flush out some of the salient points for his lightning talk. So without any further ado, I'm going to let Michael and Brian take this away and introduce themselves. We'll have Q&A in chat and Q&A at the end, so please take it away, Michael.
Okay, so hello and thanks for having me. That's a great idea. I think spending a little quality time here in interactive fashion really helps the whole topic. My name is Michael Hausenblas. I'm a developer advocate in the OpenShift team and been doing this function as a service and serverless things roughly for 2 years, a little bit more than 2 years now.
So this is Brian Gracely. I'm Director of Product Strategy on the OpenShift team as well, and have been following the serverless space for a couple of years as well. So excited about the topic today.
Cool. So let's jump right into it. If you look at where the whole thing comes from, then people would argue we had traditional PaaS and service-oriented architecture and so on for 15, 20 years already. Now, I'm not going to go out and defend things like Corba and other things, but it was around, right? This idea of autonomous services communicating in a kind of loosely coupled manner. And then some 10 years ago or so, the whole thing moved towards smaller services that have a certain purpose, and they're even more loosely coupled. And they can't be independently scaled and typically are backed up by their own data store. And automation definitely played a big role. And as a kind of natural next step, if you break down this functionality even further, you arrive at functions. And functions, essentially, the main characteristics there, it's stateless. So you don't have any kind of real state in the function. There's some scratch space. Typically, you have a few megabytes, whatever, where you can temporarily store something. But typically, they are totally stateless, and they're event-driven. So it really makes most sense when you have some kind of events triggering that function execution. Typically, we're talking about ephemeral and elasticity a lot. And that also depends quite a lot on the execution environment. And we get back to that later in terms of public versus on-premises deployment. So on a conceptual level, you have essentially 3 parts to any kind of function as a service. You have the triggers, and the trigger can be something very concrete. For example, uploading a file to an S3 bucket, for example, and that event triggers then, or you could use this event triggering then a certain function execution. You could also think in a more abstract way, for example, time, right? If you have every, let's say, hour, you say, I want to execute a function, that's also a trigger. And some of us remember good old cron jobs, right? That's essentially also a trigger. You have then this core bit that I titled just management, which typically includes a CLI, a HTTP or whatever API, and a UI. In that, a developer can upload their functions, manage them, define the triggers, and other things, logging, monitoring, and so on. And then, which is sometimes a little bit overlooked, you have, remember, functions are stateless, you have integrations. And if you don't have these integrations, it's really, really hard to use functions in real-world applications. Integrations, for example, can mean I want to store some state in an S3 bucket or a Minineo or Ceph or whatever. I have a message bus or a queue somewhere, or really any kind of external system external to this function as a service system where I can store intermediate or end results. And the main
Michael,
point, yeah.
Go ahead. I was going to ask you sort of a dumb question, simple question. So you've used the name functions as a service a couple times, sort of FaaS.
Right.
And then, at the beginning we talked about serverless. Like, Are those just interchangeable, or is there a point when it shifts from being one to the other?
Great question. Good question. I was originally, when I started off, I was like, serverless, that's so dumb. It reminded me of NoSQL, right? It's like defining something by what it is not, or what it doesn't have. And I actually blogged about it and said, like, come on, let's just call it functions as a service. Over time, I've changed my view on it because a few people pointed out that there is more, there are potentially more serverless offerings than purely function as a service. So anything that essentially allows you to not focus on provisioning, and by that I also mean dealing with containers, really on a very high level. So anything there, not only function as a service, could be called serverless. So few, or for now, I would understand serverless as being like the bigger concept, and function as a service being one particular manifestation of serverless, if that makes sense.
Okay, no, that makes good sense. Like you said, it's if you're not dealing with the infrastructure, that's more serverless, and if your application framework is small functions, that's more functions. Is cool. Thank you.
Right. Yeah. So that's on a theoretical basis. That's essentially the concept. Triggers, some bits of management, and there is where you see quite a lot of differences between the different frameworks or solutions that you have in terms of what kind of languages do they support, what attitude do they bring, do they use, for example, most of them do use containers or not, how powerful is the CLI, is there a UI or not, and so on and so forth, and integration. So this is one big thing that is sometimes overlooked. And I'm not saying that you cannot do functions as a service without these integration bits, but you're limited. You can only do, purely functional in this sense, really just calculating something, which can be useful, but is limited. Okay, if we step back a little bit, and thankfully the Cloud Native Compute Foundation serverless working group has done that work to kind of start to document and map out the offerings on different layers, platform and frameworks and so on. You can see that we are, although the whole thing is maybe 3 years old. AWS Lambda started in 2014, so three and a half, whatever years old. You still, you can already see that there are quite some offerings. So it's early days, but still there are offerings on each of these layers. The topic of our discussion today, however, is Kubernetes and how these functions as a service frameworks or offerings can be used on top of Kubernetes. I obviously have a special interest in the enterprise distribution, OpenShift. That's what I'm working on. But in general, all of those run on vanilla Kubernetes. And you see, if we start from the very right column there, that most of them are not really that old, right? There are some of them that have, started out like Open Whisk initially by IBM, part of Bluemix, already in 2015. But many of them, they are maybe half a year to a year old, right? Late 2017, mid 2017. And some of them, if you look at function, I intentionally put them into italic because we essentially at some point in time refocused, when I say we, I mean Red Hat, from doing function and putting our engineering focus and muscles behind Apache Open Whisk. And two things are notable here. We can discuss about the community size, right? I'm pretty sure there will be someone out there who says like, oh, but here you got that totally wrong. This is way bigger or smaller or whatever. This is in general, if you look at overall activity, contributors, use cases around that, what's going on mailing lists outside of the core backers of a certain solution. And what stands out here is really Apache Open Whisk, right? It's really backed by a number, obviously it's Apache Software Foundation project nowadays, but there are quite some heavyweights behind that. And I'm not saying that you necessarily, like everyone has to go all in with Open Whisk. There are really good reasons why you want to use kubeless or this or that. I think what is important is being able to have the choice here and being able to run any of those depending on what your needs are on Kubernetes, and that is what we are trying to achieve in OpenShift. OpenShift, and we particularly focus in terms of engineering resources on Apache Open Whisk. Anything you want to add here, Brian? Does that make sense?
Yeah, no, I think it's a good summary. And again, people can debate any sort of qualitative measure of it. I think that the takeaway from to me the couple of big takeaways from this are it's always good to see a number of projects because it shows that there's a lot of interest in this space. We're going to see some very interesting things come out of it. We probably could add a column here that is is there a focus of each of these projects? And I think in some of them you might see a more distinct focus. In others, subjectively you could sort of say, well, they're sort of the same thing. So the other big takeaway for me, so good to see a lot of interest in it. Obviously, there's people trying to figure it out. The other one, and you've been working on this a little bit, is while in the top column, you've got Red Hat, who's going to be backing Open Whisk as sort of the de facto one that'll be an OpenShift. We've already seen people, making other frameworks work on top of this. All right, so we've seen kubeless. You've shown that. We've seen OpenFaaS. We've had blogs about that. So I think the nice thing about this is, if as a group within a company you decide, well, we really like one of them, that's fine. Pick that and go with it.
Right.
If you like something else, great. And there'll be reasons why you do it. You like a backend data integration. You just like the languages they support. You like the community, whatever it might be. So to me, that's a good sign at this point. We may see this consolidate over the years, but good, healthy community at this point.
One thing here too is, if you go back a slide to the landscape slide, what would be interesting for me as another angle on this is, of all the proprietary offerings, which ones of the open source are underpinning some of these proprietary offerings? Like, so who's using what under the hood to add a flavor to the thing? Is that where are there enterprises? This is interesting from the open source queen here, but But I'm very curious which of these enterprise offerings are using the different open source projects as well.
Right. So I'm only aware of one or two examples here: IBM Cloud and Adobe, obviously Open Whisk. I am not sure if any of the other commercial offerings is actually using anything or something on the next slide in terms of FaaS on Kubernetes. I would love to learn about it, but that's literally the only example that I am aware of. And I'm very happy if anyone is on the call educating me here. I'm very, very happy and open to learn about that. I don't know of any other example.
Yeah, the only other one I can think of is I believe the Oracle service is based on the FN function capabilities that came from the Iron.io acquisition. But
that would make sense. Yes.
Yeah.
I haven't checked, but yes, I would believe that. Yes, that makes sense. Yeah. Mm-hmm. Okay. Cool. So the takeaway from this is there's a lot, and maybe that's a horrible comparison, but it's a bit like if I look at a operating system like RHEL or whatever, there are different, I don't know, editors or whatever. You might prefer VI, you might prefer Emacs or whatever, and there might even be a default. But at the end of the day, you get to pick what you run on it, and as long as the platform supports it, all is good. And I think that's a little bit our attitude there as well. Although we do commit, we're not on the fence. We do commit our resources to a certain project. Cool. All right. Unfortunately, we don't really have time to go through all of these different options in greater detail, and it's really a matter of let's maybe quickly go back, because you asked it earlier on or pointed at that direction, Brian, in terms of focus or whatever. There are some that focus more on usability, let's put it that way, which are more developer friendly. Kubeless, OpenFaaS comes to mind. There are others that target more like the enterprise space, that have more in mind is, okay, how are people going to use that in an enterprise setup? But my recommendation here would be that you start off by the languages you want to see supported there, and each of them has, there are some that are kind of usual suspects, like Node.js, for example. Pretty much everyone supports that. And start there and have a look at, for example, if you are in a certain environment and you work closely together with one of the providers there, you might start with evaluating stuff at that point. To me, as I said, in terms of community, Apache Open Whisk is certainly a safe bet in that sense. But have a look at the supported languages, integration points, and so on. Maybe that is a good starting point to pick the one that fits your needs. Let's move a little bit further and talk a little bit about challenges and opportunities. I really intentionally picked this phrasing to say, I'm a huge believer in function as a service. I think that it is a superb tool in the toolbox, but it is one tool and not a silver bullet. So the first question that I hear very often, I'm having these discussions with folks out there, is, does it actually make sense to use anything other than, at the end of the day, AWS Lambda or any other of the public cloud offerings in that space? And, fair point. The majority of production deployments are, in fact, in AWS Lambda. And that doesn't really surprise me. I mean, they have a huge head start and really went all in there. And Lambda plays a very crucial role in the entire AWS ecosystem. But that's just one aspect there. So, sometimes you see that and hear people arguing it's containers on the one hand and serverless or function service on the other hand. And I would say that is a little bit limiting. That is, it doesn't really help anyone to paint a picture like that, because at the end of the day, most, if not all, of the functions as service offerings on Kubernetes, remember the table earlier on, do use containers, to package and ship your functions. So maybe it's just a matter of the focus shifts, and the containers are less visible to developers. There are some that where you can explicitly, use containers as well, but typically you don't really get to see them. So it's essentially not only serverless, but these bits or these infrastructure parts are not visible to the end or to the developer really, and don't play any role there. At the end of the day, that means I, as a developer, don't need to worry about, is it this image or that, scanning, anything security related really. I just say, this is my code, go and execute my code. There are a couple of examples where the public cloud offerings are sometimes too restrictive. Just to give you an example, the default that I checked earlier in AWS Lambda is still 300 seconds. So that's 5 minutes. That's not bad. But if you have anything longer running, then you need to split it up and you need to coordinate. You need to, put intermediate results somewhere else, and you need to do that on your own. So I'm not saying AWS Lambda is bad. All I'm saying is, if you're running that on your own Kubernetes cluster that you might already have in place anyways, then you get to choose. You can say, okay, I need, 500 seconds or maybe 10,000 seconds, whatever you need for your use case. And that is just one example. There are many, many others where, because you're in control or someone in your organization is in control, you have the choice to make it work for your use case and not need to bend over backwards to make it work. The other aspect there is elasticity. And that is something where I would say, yes, it's true that in the case of an on-premises deployment, so if you have your data center and you have 10 racks there, well, you can't rack up something there within a few seconds. That's where public cloud deployments shine. And but no one is, or it's not the case that you cannot, or put it in a positive way. You can of course deploy Kubernetes in the public cloud and benefit from auto scaling there as well. So all in all, no matter if you're on premises or in the public cloud, using these FaaS on Kubernetes service deployment options early on mentioned gives you portability and the freedom to do what you need to do for your use case.
Yeah, I was gonna add one other sort of aspect of this. I think to me, I always look at this as there's two other elements that are kind of worth considering. The first one is, and this doesn't have to be AWS specific, but it's really sort of any cloud specific, is which data services do you want to be specifically tied to, or do you necessarily want to immediately leverage? And this is where there is some significant differences between even what, say, AWS does versus Azure Functions versus Google Functions, but also, if you were using Open Whisk or you were using kubeless, you're going to have different sort of native connectors that are going to be available to you. That may very well come into play as to what's important to you. We've heard different companies who will tell us, I want to use serverless, but maybe I don't necessarily want to be tied just to one of them. Is there going to be a way to run the same service, same operations in an Azure? So that's one of them, I think. The other one I think that comes into play, and you mentioned like pricing and so forth. I think you need to consider. This is always the conversation that comes up of like, do you deal with containers or you deal with serverless? I think it really comes down to who's going to manage the sort of development of the functions, and then who's going to manage the underlying platform. If you have no capabilities or no interest in managing the underlying platform, using one of the managed clouds is probably the way to go. If you're capable of running a Kubernetes environment, at that point you more or less have the skills necessary to be able to spin up immediate resources, scale resources, and then you've got some more flexibility. So definitely more than just saying sort of lock in. I think it comes into what do you want to take into consideration? Your data, how you operate it, and then how portable you want the system to be, not just an individual function. The function is pretty portable. The platform has some other considerations.
Great point. That's exactly what I meant. I might not have used the best words for it, but what the thing that comes to mind is really trade-offs, right? You are either on the one extreme willing to say, well, I'm fine with feature or vendor or whatever login, and for that I get everything managed. It's very convenient. I don't need to take care of anything, and I know that it will be hard or difficult to then move somewhere else. On the other hand, if you are into that where you say, okay, to me portability is of importance, and I want to have a certain level of decoupling in terms of data stores or whatever, then this is the actual trade-off there to at some point in time you have to decide. And great point. Now moving on to you can call it controversial topic, but to me it's so central, and I was surprised when I learned some reactions to that topic. I initially end of 2016 wrote that book Serverless Ops for O'Reilly. It's like 60 pages or whatever, and you can grab it for free on this webpage. And there it was in one of the chapters I talked about that already. And only recently I blogged about that as well, asking essentially who's on call. And by that I mean really no matter in what setup. One extreme might be AWS Lambda, another one might be, Open Whisk and OpenShift on premises in your data center. The people who run the actual platform, Kubernetes and Open Whisk, for example, you typically don't really, as a developer, have access to them. In AWS case, it's very obvious, right? You simply cannot reach out to an admin there and say, hey, I have that problem. And even if it's within the in the organization, we have someone. Can you mute yourself?
I'll work on muting it. You can go ahead and keep talking.
Okay. You simply cannot assume that someone in the admin role will be around. And that means that at the end of the day, you have to ask yourself, if something goes wrong in that function, if, in terms of logging, monitoring, or whatever, who will carry the pager? Since Or if you subscribe to that idea that you do not have access to ops folks that take care of stuff, because at the end of the day there will be servers somewhere, who's on call, right? Who will be the one who looks after a function or a set of functions typically working together? And there, my conclusion was essentially, well, it probably will be the developer. So if you're developing a function and uploading it to one of the frameworks here, then at the end of the day, it's probably you who will be on call. You will be responsible for that. And I asked that question, and there are some out there who say, yeah, of course, that's our attitude. Our developers are on call. Others say, well, we pay our developers for writing code, delivering features, and not for these ops things. And I'm not going to argue here. As long as you're aware of that and have a some policy around that, that's cool. The problem is that I think many enterprises who buy into that and adopt that paradigm are not aware of it, and that is a problem. If you're not aware of it, then at some point in time, this will probably bite you in the behind. So you better have a policy and a strategy around that. That's my main point. What do you think, Brian? Is that too extreme, or
No,
I'm still kind of like trying to figure.
Well, I think it feels like it moves the conversation a little bit. So in the past, if let's say you were a developer and your application interacted with the database, let's keep it simple, right? You probably had some organizational way of saying, okay, if let's say the application doesn't work, I'm getting certain error messages. That's an application problem. But if the response time of the application is slow, when would I engage, say, a DBA, for example, who wouldn't necessarily be a developer, would be sort of considered. I think this is in the same vein of things, because if we take a serverless application, let's take let's take your example where something comes in through an API gateway. A picture, for example, a file gets stored in S3, a function changes that into a thumbnail, and then it goes out to a web page to be displayed, right? Simple concept. You really have the same idea there, right? So if the picture didn't get transformed, well, that's probably an application problem. But if an API call didn't happen, you get a 404. Who do you talk to at that point, right? Is that an ops problem because it's an API gateway thing? Does the developer have to know about the API? Mm-hmm. So I think that's really what it is you want to take probably similar constructs as you had before, right? Where does the application stop and start? And then beyond that, what are you willing to do? And that all might be the same person, or you might have sort of a set of operations people that are now dealing with all those sort of inputs and outputs, right? Sources and sinks, if you will. But yeah, I don't think there's an answer. I think it depends on what your organization wants to be able to do. But I don't.
Absolutely.
It doesn't go away. I think that's the key. Is it doesn't go away.
Yeah. I think that's a fair summary.
It also changes the nature of the developer role as well, because a lot of times developers are brought in just to do the code and not to maintain the application for the life of it. So it maintaining the relationship with the developer for the life of the application becomes something that you're on the hook for as an organization.
Yeah. I guess my initial reaction, especially back then when I wrote the serverless ops book, there was that I can't remember who did it and where it came from, but this term "no ops" that really rubbed me off the wrong way. It was kind of like suggesting, oh, there is no ops aspect. Of course there is. It's just it's even further, like it is already there with containers. You have certain best practices in terms of logging and metrics, think about Prometheus and other things. So that awareness is already there, and the more developers care about that and are aware of that, the easier this whole DevOps into play is. And with serverless, with function service, this goes even further, is more extreme. So calling the whole thing no ops to me is really suggests the wrong thing. That's probably the main motivation behind that.
Yeah, it's sort of dawning on me, like we start talking about microservices and people say, okay, you're gonna break up into two pizza teams, right? That concept assumes that the other team that you're working with is people, right? Maybe this is the way to think about it: is what do you do if the thing you're dealing with is a two pizza API? Like, what's your contract with an API? from an ops perspective, because that's ultimately what you're going to be dealing with, right? And if you don't know the answer to that, or you haven't explored it, then you're going to have a challenge. But that's what you're dealing with. Is I'm now dealing with an API, and I don't know what the team is behind it.
I like that. I'm going to steal that line, the two pizza API.
Right.
I'm going to use that. Awesome. Cool. So wrapping up that slide really here, I don't think that there's a right or wrong. And as Brian pointed out, there are many different models possible. Just be aware of it. Just don't buy into that no ops thing. Oh, we don't have any ops issues anymore, right? Someone somewhere will have to take care of that. Be it logging, monitoring, optimizing, runtime, whatever, troubleshooting or profiling. Cool. Last but not least, my favorite picture, and that's, I think, a wild popular meme going on up and down on all the social media, the the half drawn horse there. So if you have a handful of functions, and many use cases actually started like that. If you look through the success stories, AWS Lambda or anywhere else, there are countless serverless conferences, ChefCon and many others in many cities nowadays. It's a handful of functions, right? It's maybe 3, maybe 5, maybe 10. It's in general not a problem. However, imagine you are in an environment where either directly or indirectly over time, you're more or less breaking up a monolith, or even if it's like initially 10 microservices, into 100, 200, maybe even more functions. Remember, a function really has a very, very small scope. So does that somehow familiar to the problem we had with containers, right? As long as you did, running a container on your laptop, you don't really need a container orchestrator. As soon as you start spreading out hundreds of containers over hundreds of nodes or whatever, you probably want something that orchestrates the bits. And as far as I've seen, always in the open source context, this is a rather underdeveloped space so far. The only thing I'm aware of, and again, I'm very, very open to if someone can point out some other examples, is IBM's Composer that tries to achieve that. And I think it's even worse. It's actually, we are not even in a position yet that we can actually point out, like, what is such an orchestrator supposed to do? Is it things like dependency management between functions, cascading of functions, which typically in public cloud environments are not really encouraged or allowed? Is it how functions communicate? You have something like Kafka or whatever there for inter-function communication. So it is really early days in terms of orchestration, but at some point in time, if that whole thing, and it will take off, you will end up with a lot of functions. And you might be laughing about it, but even thinking about having a kind of registry of available functions, if you have a certain base functionality and say, well, why should I over implement the same functionality? I might put that there and people can reuse that function. Who's going to do that? Is it your spreadsheet, or maybe you have something else there? Maybe you have a registry or whatever there for functions. So wrapping up this one here, it might not yet be a problem because we're dealing with not that many functions so far, but at some point in time, we will probably very likely need some orchestration bits here as well. One example, as I said, I'm aware of is this Composer thing from IBM. There are a couple of resources if you're interested in any of these things, want to dive deeper. If you want to be active, come and join us in CNCF, the Cloud Native Compute Foundation Serverless Working Group, on Slack, GitHub, there are meetings and so on. I want to also point out my thanks for Chris Swan to maintain this FaaS and Kubernetes inventory on GitHub. He's documenting stuff there, and William, who gave quite a lot of input regarding the Open Whisk bits, and various people on Slack and in person and so on, who helped shape these topics and these comments there. Okay, that's, I think, already what I've prepared here. Yeah, so I'll just leave it here, and I guess we're good to keep the conversation going and potentially have questions.
So it's been interesting while you've been talking in the chat channel. Adit has brought up yet another project around in the same space that's about 3 months called Glue. So it's, as you say, it's a challenge keeping up with all of the different offerings. So thanks for taking time to do this today. I'm see if Brian has any final words to add to this, and I'm not seeing any questions in the chat. So pop in if you have a question, and we'll be happy to add to this.
Cool.
Yeah. So I'll throw out one comment, and then I'll throw out a question, and then anybody can throw some into the chat as well. I know we talked a lot here about sort of developers building functions, so application specific things. I think there is a whole set of people that are using this for operations too. We've heard a lot of people that are looking at repetitive tasks that they have that they do for operational things, whether it's inventory management or things for upgrades or whatever, and they'll take everything from like an S&P trap to an alert from a system. That'll be their trigger, and then they'll kick that off. So, one thing, my one observation is, like, if you're on the operations side, don't necessarily ignore this, because this may be one of your favorite tools.
Right, absolutely. And I don't know if it's true. I heard a story that I literally heard it. I didn't read it. So if anyone who has some relation with AWS or AWS Lambda can confirm that, or tell me that's not true, it would be interesting to see. But I heard the story that AWS essentially was looking at patterns, how people would use EC2 instances. And one pattern that kind of emerged over time, and which apparently then led to the introduction of Lambda, was that many, especially ops-related tasks, were essentially ramping up an EC2 instance, then doing something for a minute or two, and then throwing it away again. And they looked at that's the rumor here. Like, how can we make that pattern better and more efficient also for them in terms of utilization? And it's absolutely true. Like, you see that very often. It could be, a replacement for a cron job. It could be anything, like you have something on S3 and you want to clean data or transform it or whatever. Very, very often this kind of ops related use case.
Looks like there's a question asking about functions deployed in Kubernetes pods.
Those existing serverless frameworks, are the functions deployed as a Kubernetes pod?
Right. So in general, all of them I'm aware of are, obviously, since they're running on Kubernetes, at the end of the day, creating containers in pods. How they do it is different. One of the big challenges is in terms of, if you think expectation-wise, in terms of how quickly should a function execute. And that means that even the very, like, container, once the image is pulled, obviously, can start up very, very quickly. It might still be not fast enough. So if you want, for example, let's say an SLA where you say the function from whenever it comes in through the gateway, whatever, the invocation time must be below, let's say, 100 milliseconds or 10 milliseconds, whatever, you might need to, or the frameworks actually do employ some tricks there. They have pods already running, or containers in these pods already running on standby. So they're kind of like hot, they're already running. And when the trigger actually triggers the function execution, they don't need to be spun up anymore. So how they do that differs, but in general, yes, all of them essentially use the ones we have talked about, FaaS and Kubernetes, use containers there. Yeah.
So I'm just going to ask a question too, because I'm kind of curious about the monitoring of serverless applications. It adds in, I mean, we're all getting used to monitoring pods and containers and all of that, but serverless as a function kind of boggles the minds how you keep track of all the moving parts. And what is sort of the state of monitoring FaaS?
Right. So we have already seen that this big transition from this traditional monitoring of host level thing, where it's okay, since the VM or whatever lives for weeks or months, it's okay to kind of like think of monitoring or whatever as an after the fact thing. Obviously, with containers, that doesn't work anymore because of the lifetime of the containers. So you need to be much faster there, being able to have the monitoring and logging in place immediately. And that is obviously also true, and even more true for functions. The other aspect, and I actually haven't seen much there either, is that of distributed tracing in this context. This has already, become sort of very, very popular in container orchestration. So things like, for example, Jaeger, or any open tracing based system is becoming kind of like the standard. People need that, and obviously that is also true and valid for function as a service. So you want to know that, especially if you have a couple of functions working together and dependencies there, dependency graph, where is your bottleneck? And for that, you need, at the end of the day, again, distributed tracing. So whereas monitoring and logging might be relevant for a particular owner or developer for a single function, looking at an entire application that is made up of 10 or hundreds of functions, I think a distributed tracing tooling around that is almost a must. It's not optional, I guess.
There's a bunch of questions coming in now. William's asking, are these projects extending Kubernetes services with CRDs, or are they just deployed as another app on top of Kubernetes?
It very, very much depends on what you're looking at. If you look at examples here, some of them, they were not developed, how to put it nicely, with Kubernetes in mind, or they kind of like evolved in parallel and were then optimized or made compatible with, so that they run properly on Kubernetes. Others were more or less like kubeless. It's a good example, right? They were really born as Kubernetes applications. It really depends. The main thing, and this is really more probably interesting for someone who is operating that and who probably wants to extend that. The main thing is that the interface for the developer is essentially, here is how I can package and upload my function, for example, or my functions plus resources. Here is a zip file, put that to that HTTP, put that to that endpoint, for example. Oh yeah, I have a nice UI or whatever. How do I define the triggers? How easy is that? How powerful is that? It really, really depends. The implementation details really they differ quite a lot in terms of what they expect, what they assume in terms of the runtimes and so on. But in general, yeah, everything from CRDs and yeah, lower level extension mechanisms are used.
Right. There's a sort of a, this might be a Brian question too, but Paul's asking an interesting question from a provider perspective. How do you charge for that type of service? They offer an on-premise OpenShift offering and charge by utilization and promote scaling, obviously. If they're running containers on hot standby now, how do you foresee charging model for end users in on-premise infrastructure? He doesn't see the benefit.
I'm super happy to leave that to Brian.
Yeah, I think there's a couple of things, and we won't sort of skip it, but it's not a simple question. I think, how you charge people, whether it's a chargeback model or, sort of known pricing for, amounts of time or whatever, the guidance I always give to people is, go look at what the public cloud does, because in essence, your end customers will use that as a baseline, right? So they will say, okay, the cloud gives me an option to charge things by the month, or they charge me by the hour or by whatever. In the case of something like Lambda, they tend to do it by like number of transactions that you spin up, so 1,000 or 1,000,000 or something. Use that as a starting point. You don't have to use that as what you actually do, but it gives you some sense of, okay, this is maybe what people are going to use to make comparisons of, should I use your service or should I use a different service? The other thing is, I think you're going to find that the more you can chunk it up into things that people will typically use, like you kind of have to understand some use cases. You may have a completely different charging model if you say, we will run your application, and then you can use something like functions for certain operational things, right? For upgrades and monitoring. Maybe that is included for free. Whereas if you say, we're going to build, we're going to do this for your direct application, a Node.js application or something like that, maybe you then charge it more like you do for applications and so forth. So not one specific thing. Would be happy to, kind of follow up and talk to people about kind of ideas around it. But I think it kind of depends on what do you think people are going to be using it for? Can you break it up into sort of self-servable chunks. But be aware of what the public cloud's doing, just because people will compare your pricing or your offering to what else is available to them, and they may use that for comparison reasons or budget reasons.
All right, and then there's a couple more questions. Eric is asking, is there a role for managing locality, co-locating functions that talk to each other for improved performance?
Right. I'm not aware that there might be, somewhere deeper hidden something. The thing is that in general, the attitude there is a little bit with like container. You should not necessarily know or make assumption where stuff is running. Now, there might be a good reason, which especially is true for data. If you want to have data locality, for example, you have data on a certain node. Again, in the case of Kubernetes, if you have any of these public offerings there where you don't have any insight, then that's not true. But wherever you have this insight and possibility to do something, the underlying constructs being things like pod affinity and stuff like that. So I'm not aware. I can't give you an example there. It certainly can be useful, and that is maybe something that could actually be part of the orchestration as well, to make that, to explicitly state dependencies in a declarative way, that you say, this group of functions or these two functions, whatever, they run best or better or whatever if they are close by, and or with data, and to be more concrete here, for example, you have this data locality essentially built into all these big data things like Spark and Flink and whatever, where the basic idea is that rather than shipping data across in the cluster, you're shipping the code to where the data is. So it's really, when you say locality, the question that pops to mind for me is mainly what kind of locality is necessary or is useful for your use case.
There's one other question which actually makes me think that we need to do a deep dive into Open Whisk or something, and so that we can actually a demo of how this actually all works. Briefing.
Yeah.
So Albin is asking, when deploying a function as a pod, does it need to build a container image first, or so that image contains compiled code, or do people only use interpreted languages? But yeah, this strikes me as another whole topic, but
right
for that.
Right. So the main point being that you, as a user being the developer here in this case, you don't need to take care of that, right? You really just say, here is my source code, Node.js, Python, Java, whatever, and there is some mechanism to package that and give that to the respective framework. And what happens then is really up to the framework, how they essentially inject it. They build an image around that, if they inject that live, and so on and so forth. As a user, as a developer, you don't need to have, or you're not dealing with container images or containers in the first place.
Yeah, it's and it sort of explains why, if you took this at a really high level and you said, well, serverless on Kubernetes is containers, I should be able to run, any language I want, anything I want to, and then you look at the projects themselves and they only support certain languages. Part of the reason for that is, some languages wouldn't make sense for small functions, but in other cases, managing the behind the scenes of how do I get it from just code into something that'll run, that has to be a function or a capability of the platform, right? So, in the OpenShift world, right, what we've done with containers is we've said you can give us a full container, or we can use something like S2I. That all of these things have to have some sort of like a S2I type of function that's going to get you from your code into some operational state. So again, this is going to be kind of project dependent, which languages it supports, and you have to have a little bit of awareness of that. But to your point, like as a developer, the whole goal of this should be you shouldn't have to know about any of that. We'll take care of it. But they'll end up probably being certain limitations and versions and stuff like that.
Yeah. some do expose that, some allow you to do that, but in general, that's exactly the goal, right? You're not dealing with any kind of provisioning, including container image building or whatever. There was one more thought I had, and maybe that's kind of like, at least from my side, the kind of final thought on that topic. As I said, I totally believe in FaaS and serverless, but being aware of it's not a silver bullet. It doesn't solve all your problems. There are use cases where it's probably not a really good fit, and in that sense, it's really one tool in the toolbox, and that's what I like about that. This Unix philosophy in terms of toolbox. You have different tools for different things, and FaaS being one tool in the toolbox. And there are other cases where you have where you're probably better off with a permanently running container, and then paying the price for it. Essentially, you have to deal with building the container image and so on and so forth. It's one tool, and it's a very useful tool.
Any closing thoughts, Brian?
I think we covered a lot. My big takeaway is, this is an exciting space in terms of, we've evolved to where there's communities around this, so people have some choices, which is great. Gives them some choice of project, but also say choice of cloud or platform. I think it should be pretty obvious. This is still pretty early days, right? There isn't necessarily 100% standards, and we still have lots of projects. So be cognizant of that. But the biggest thing I think is, if you're interested in this space, like, get involved. I mean, there's a lot of places to get involved. If you want to, we'd be happy to find you, help you ways to get involved. But if not, jump in one of the projects and see what's going on. My only last one is, if at some point somebody in one of your meetings or one of your developers says, we're going to take all the applications we have today and we're going to move those to serverless because we don't have to pay for anything, like, throw up the biggest red flag you possibly can. And I don't say that jokingly. Like, I've heard that from more than my hands number of customers that just say, I don't want to pay for anything anymore. We're just going to move all of our applications to serverless. And that's a big hill to climb if you think you're going to go down that path.
Yeah. No servers, no bill. Absolutely.
Yeah, that's right.
And just to clarify, or to phrase it in a more positive way, when you said contributing, very often people think, what we mean by that is, writing code or whatever. Not at all, right? You can just grab one of these things, pick one and do something with it. Try it out in your environment and give it back to the community. Blog about it. Say, hey, here's my use case. Here are my experiences with tool X, and that helps all of us to see, edge cases better, to see how could such an orchestrator, what would be the responsibility there. So contributing really does not mean that you need to write or contribute to one of these projects. Of course, we're happy if you do, but it really just means use it and share that usage experience with the rest of the community, that everyone wins.
I couldn't have said it better, so thank you for that, Michael. Contributing and collaborating and giving feedback, doing demos, all of these things are essential to moving these projects forward and all of our projects forward. So thank you guys for having this conversation with us today. Yes, someone's asking, we need a deep dive session showing how it all works on Kubernetes under the hood. So I think there are a few resources around, a demo link here for Open Whisk on OpenShift, but I think we will try and probably post Red Hat Summit when everybody's breathing again. Set up an Open Whisk on an OpenShift deep dive and expose some of the underbelly of how it all works on Kubernetes. So thank you guys again for your time, and we'll talk to you all next week.
Thank you, and thanks for the great questions, folks out there. Thank you.